Amigos de Data Evolution, y nos encontramos aquí en el MIT con Gabriel, que es responsable de construir los robots que vemos aquí. Es doctor aquí en el MIT de la área de robótica. Thank you for your time. And I just want to understand what's the challenge to build a robot? What do you need to know and understand to build a robot?
Right, so I would say that robotics is a very multidisciplinary field. And if you want to build a robot, you need knowledge across all sorts of engineering disciplines. So that includes mechanical engineering, electrical engineering, computer science, artificial intelligence. Personally, my area of focus is on the computer science and artificial intelligence. There's been kind of tremendous progress, I think, across all of these different aspects, like both the mechanical design and the AI powering the robots. But if I have to pick one as the biggest challenge, I would say right now it's the AI.
The AI.
Yeah, and that's because, so the fact that humans can teleoperate it suggests that the hardware is sufficient to do those useful things. But the fact that the only gap that remains between that and already doing useful work, I think, is really making those robots autonomous, and that's what requires AI.
Ok, bueno, uno de los grandes retos es la inteligencia artificial, que ya lo vemos aquí en los letreros, todo lo que nos está explicando Gabriel. What do you think is going to be the market within the next 10 years?
So currently, I think the market for robots is relatively, I think it has a huge growth potential. And right now it's not as large yet, like especially if we're talking about these kinds of mobile and dexterous robots. They're mostly being deployed in applications of inspection, where they need to walk around and look at, for example, they're carrying some heavy, expensive sensor payload, and they're walking around a factory looking at different parts and sending back data. So the reason for this is because these robots are good at walking around and they're good at navigating very structured environments, but they don't do as well yet, or they haven't done as well using previous approaches, where the environment is very unstructured, like a home or a public space, and they haven't done as well at interacting with the environment, where they need to manipulate objects, open doors, things like that, as compared to walking around and climbing stairs. So I think that those are the kinds of challenges that our research is about, and those are like problems that are within reach for the next few years.
That's right.
For robots, not necessarily to be like a human level manipulation or reasoning
or
agent,
interaction.
or interaction, but to be good enough to start being deployed in some of these applications. So I think like the first areas that I'm excited about are, and where I see a lot of progress, are in factories. For example, like heavy industry, automotive, repetitive tasks. Where it's not so repetitive. If it's already perfectly repetitive, there are probably already robots there, like a robot arm that's doing the same motion over and over again. But there are some repetitive tasks where there's a bit of variation. You need to see, whether there are defects on a part, or you need to attach two components together in a way that's not exactly like repeatable, that you can just repeat the same motion and get the same result every time. So where you need your robots to be a little bit adaptive, I think those are going to be the next things. The second area that I'm excited about is home robots, and I think it's a very big open question how long it will take for robots to be useful in the home setting. I think there are companies that say they want to do it in a few years, doing things like folding laundry or like helping with your dishes. Of course, there are already robot vacuums, right? So we already have some
we already have
foot in the door. I'm expecting, progress. Maybe it's not like overnight we're going to have an amazing home robot, but I do expect some progress.
Liquid networks. This is a brand new concept. And what is liquid networks and how is going to impact this market?
Yes. So, I'm not an expert on liquid networks. I'm an expert on robotics, but I do understand liquid networks. So. Liquid networks are kind of a new neural network architecture that can potentially learn from data more efficiently, more expressively than the existing kinds of architectures. So this is important is a lot of the new progress in robots is driven by learning from demonstrations or learning from data that's generated by a simulator. But in order to learn, the first step is to generate that data or collect those demonstrations. But the second step is to learn, like train some kind of neural network on that data and then apply it to new tasks. The two questions are always, what's the most, can the network really absorb all of that data? And how well does the network generalize when it sees new data? For example, if it's seen a bunch of examples of cleaning kitchens and then it's placed in a new kitchen, how well is it going to do? So these two aspects are where the neural net architecture can really make a big impact. And the liquid neural networks are quite new, so I can't fully predict the impacts, but I think like when it comes to the need for new more powerful architectures, it's definitely going to help robotics in that like learning from data.
Definitely, it's gonna help liquid networks. Last question about robots are gonna grow massively in the next 10, 15 years probably. What kind of infrastructure will be needed to control robots? I mean, data center, edge computing. Today we have IoT, and you have in the cloud every collect data for you and then goes back to the user.
Yeah, I think it's going to need all of it. And really, what I expect is that there will be different functions of the robot that are running in different places. So when it's critical for the robot to respond very fast, for example, when it's walking and it needs to maintain its balance, those types of AI systems will run on board the robot because it's essential for the communication to be very low latency. And you don't want to like lose your internet connection and then fall over.
Yeah,
this would be bad. So like all the safety critical and fast kind of components of the system, I expect they'll run on board.
Is it going to be like a mix between on-premise, on-board, and then the cloud?
I definitely think there will be lots of aspects that run in the cloud. And in particular, if you think about deploying like a large vision or language model on these robots, when they're really doing kind of more complex reasoning and planning, it will make a lot more sense to run those programs on the cloud. Because I think like, no matter how good computers get, we're always going to want to use as much compute as we can to do those like very cognitively heavy things. And there's a price to putting like a big GPU on a robot, which is that you have to put the battery on the robot. So like the GPU consumes lots of power and it weighs a lot. And so this is an expense both in building the robot, but then also like when the robot's moving around, it needs to carry all that weight and the weight of the battery and the weight of the GPU. So I think for those tasks that are not like real-time critical, and that includes these planning and reasoning kind of things, I think it'll definitely make sense to communicate with some kind of cloud.
Estamos aquí con Gabriel, disfrutando y conociendo un poquito más de lo que se está haciendo con la tecnología actualmente en el MIT. Gracias, Gabriel. Thank you very much.
Yes, thank you.
And continuamos aquí en el MIT.